Assalamu alaikum friends, my name is Hasabad and today we are going to complete our next numerical, which is the numerical 11.2. So without wasting any time, I'm going to read the statement of the numerical 11.2 and you can see the number 11.2 on your screen on the Excel sheet. And the statement is, if at Anarkali Bazaar, Lahore, intensity level of sound is 80 decibels, what will be the intensity of sound there? So we have to calculate the magnitude of the sound intensity of an unknown sound at Anarkali Bazaar, that is capital I is equivalent to, which we have to find, and what magnitude of the physical quantity has been given by the examiner, that is sound intensity level, is equivalent to L minus L naught is equivalent to 80 decibels. As I have discussed in the previous class or in the previous numerical, that whenever you see the word level with any of the prefix, whether that particular prefix is sound intensity or whether that particular prefix is decibel, whenever you see the word level with any of the prefix, then it is suggesting, it is indicating, it is reflecting that the examiner is talking about a factor which is L minus L naught, which is the loudness of an unknown sound in comparison to the loudness of the faintest audible sound, which is pin drop. So keep this particular indication or keep this particular hint or keep this particular indicator in your mind while doing the calculations of the Weber-Fitness law or these problems as well. Okay, L minus L naught is equivalent to 80 decibels. And magnitude of the sound intensity of the faintest audible sound, you know very well, is equivalent to I naught, which is the sound intensity of a pin drop is equivalent to 10 to the minus 12 watt per meter square. What we have to find, we have to calculate magnitude of the sound intensity of the unknown sound is equivalent to capital I is equivalent to, we have to find. So using the formula of Weber-Fitness law, and the formula is sound intensity level is equivalent to L minus L naught is equivalent to 10 times the logarithm of the ratio of the sound intensity of an unknown sound to the sound intensity of the faintest audible sound. So by putting values, we get L, which is the loudness of an unknown sound, L, which is the loudness of an unknown sound, is 80 decibels, minus L naught, which is the loudness of the faintest audible sound, which is the pin drop. And you know, whenever the pin is dropped, the loudness produced is very, very low, is too much low that we can consider or we can neglect it, or we can consider it as 0 decibels. So by putting 0 decibels, 80 minus 0 is equivalent to 80, and that particular whole factor is equivalent to 10 times the logarithm of the sound intensity of the magnitude of the sound intensity of an unknown sound to the 10 to the minus 12. Okay. As 10 is multiplying on the right hand side of the equation, so whenever we shift it on the left hand side of the equation, then the 10 will be divided with the factor of 80. So dividing 80 with the factor of 10 will get 80 divided by 10 is equivalent to 8. And 8 is equivalent to logarithm of capital I divided by 10 to the minus 12. As 10 to the minus 12 is acting as denominator of the factor I, so when we shift 10 to the minus 12 as the numerator, then 10 to the minus 12 will be converted into 10 to the power plus 12. So there is an expression that 8 is equivalent to logarithm of the capital I multiplied by 10 to the power plus 12. So by using the properties, by using the characteristics, by using the logarithm, the logarithm of the capital I multiplied by 10 to the power plus 12 will be converted into logarithm of the capital I plus logarithm of the 10 to the power plus 12. So the power 12 of the factor 10 will be shifted as a coefficient of the logarithm by using the properties or the concepts of log. So 8 is equivalent to logarithm of I plus 12 multiplied by logarithm of 10. By putting the value of log 10, we'll get log 10 is equivalent to 1. So 12 multiplied by 1. When we multiply 12 with 1, we'll get the answer 12. So by shifting 12 on the left hand side of the equation, it will be subtracted from positive here. So plus 8 minus 12 is equivalent to minus 4, and we will be left on the right hand side of the equation with the factor of logarithm I. So we have to calculate the magnitude of the sound intensity of an unknown sound. So to calculate the magnitude of the sound intensity of an unknown sound, we will take the anti-log on both hand sides of the equation so that we will eliminate the factor of log on the right hand side of the equation. So by taking the anti-log on both sides, the anti-log will nullify the effect of logarithm on the right hand side of the equation, and we left with the factor of capital I, which is equivalent to anti-log of minus 4, which is equivalent to 0.0001 watt per meter square, as it is not in the standard scientific form. So you have to convert it into the standard scientific form, and the standard scientific form of that particular factor is 1 multiplied by 10 to the minus 4, as we have to shift the decimal point towards the right hand side and up to 4 decimal places. So whenever the decimal point is shifted towards the right, then the powers of 10 is expressed in negative numbers. So standard scientific form states that the number should be that the powers of 10 should be multiplied with another number. It should lie within the domain from 1 to 10. So the factor 0.0001 in standard scientific form will be expressed as 1 multiplied by 10 to the minus 4 watt per meter square. So that is the magnitude of the sound intensity of an unknown sound, which you have to calculate. So that is the end of the numerical 11.2. If you have any query, you can say that question, you can contact me on the WhatsApp, or you can discuss it in the live class as well. Take care. Allah Hafiz.